Many of us discuss how literacy and science are related in a primary school classroom. We talk about the links between being able to write explanations in both these subjects. However, how often do we try and find the link between science and mathematics? As VC states, at the heart of science is mathematics. Science, whether in a research laboratory or the primary classroom, relies on the collection of quantitative data so that comparisons can be made, patterns and trends noted in order to draw conclusions. If science and maths are in fact natural partners, why do we teach them separately? This leads us into the broader debate surrounding cross-curricular approaches within science and maths. In the new national curriculum, the Mathematics Purpose of Study explains how maths and science are connected. Historically, cross-curricular work has been linked with more child-centered and constructivist approaches to primary education, which in the last 100 years has been recognized by the Hodel Report of 1931, the Plowden Report of 1967, and by many different school council publications in the 1970s. The statement in the Plowden Report that children's learning does not fit into neat subject categories is repeatedly used to support and encourage cross-curricular approaches. According to Carr, the 1960s, the 1970s and the early 1980s saw a change in organising the curriculum in primary schools around cross-curricular topics, projects or themes. However, in 1988, the national curriculum was introduced to schools, with its focus on programme of study for each individual subjects. This led to a move towards discrete subject teaching in primary schools. As Gillard pointed out, it divided the curriculum up into discrete subjects, making integrated topic and project work difficult, if not impossible. This larger focus on teaching discrete and separate subjects was furthermore encouraged by governments following the Three Wise Men report by Alexander, Rose and Woodhead in 1992. This report criticised many primary school teachers on how they do not have the skills to teach subjects effectively and that there is also a serious lack of specialist expertise. Even though discrete subject teaching had become more widely accepted in many different primary schools, a study conducted by Boyle and Bragg revealed that students continue to be educated in a cross-curricular manner, at least for some of the time throughout this period. In recent times, the idea that discrete subject teaching and cross-curricular teaching are equally special has been challenged by Rose, who supports the grouping of discrete subject teaching and well-planned cross-curricular themes. Making science interesting and enjoyable is one of the main features of effective science teaching and learning. Developing effective and important cross-curricular links helps students to appreciate the significance of scientific ideas, facts and skills. Many schools may also have a more practical reason for developing cross-curricular learning, just as Boyle and Bragg discovered. They revealed that schools which developed cross-curricular links were able to create a broad as well as balanced curriculum. Hayes discovered that well-planned cross-curricular work helped children. It made them understand their learning as they were able to use the knowledge and skills that they had learnt in one subject and applied it to another subject. In the case of many children, maths and science are exciting subjects that work effectively together. They provide the opportunity to practice and improve their skills and knowledge gained from the other. However, for other children, the subjects do not work so well together. The way in which teachers approach these subjects can importantly affect this relationship. Some children that are taught maths separately find the nature of maths unnerving and therefore have reduced self-confidence. Science is able to provide children with a great chance to utilise a variety of math skills within an appealing environment. Kerry, who strongly supports cross-curricular work, argues that individual subjects only give a limited insight into a specific problem or topic. So in order for children to fully understand the problem, they need to be encouraged to pick out and combine insights from different subjects. As well as having benefits to cross-curricular approaches in school, there are also a few challenges faced. The main challenge that teachers face when developing cross-curricular work is time. This is the time-consuming work and should not be rushed. When planning cross-curricular work, teachers need to plan and research the topics in advance and thoroughly explore the links between maths and science. There are vital factors which need to be taken into consideration, such as prior knowledge, skills, and differentiation. This also leads into planning. Planning may take longer, and implications may arise in long, medium, and short-term planning. Implications in assessment may also rise as the topics and subjects are combined. Rennie et al. Discussed the struggle of assessing students' learning when applying a cross-curricular approach. They argue that the traditional forms of assessment are difficult to apply because they focus on assessing specific subject knowledge. This form of assessment does not take into consideration on how children apply specific subject knowledge. However, this does not mean that assessment for the cross-curricular approach is impossible. Hiscock emphasizes on how important both maths and science are combined in terms of skill and understanding. She focuses on measuring, presenting data, and interpreting data. This also connects in with part of the new national curriculum in section 5.2 of Numeracy and Mathematics. Pupils should understand the cycle of collecting, presenting, and analysing data. Nearly all the skills that are used in maths lessons are also used in science lessons, such as analysing, measuring, observing, making notes, estimations, problem solving, recognising patterns, fair tests, probability, experimenting, controlling variables, and many, many more. A teacher can also apply this practically in the classroom through interdisciplinary teaching, which involves applying knowledge, principles, and skills to more than one subject at a time. In this case, maths and science. These two subjects can be combined by a central topic or theme. There are benefits to this if planned correctly and effectively. Resnick found that interdisciplinary teaching can increase students' motivation for learning, and it can also increase the level of engagement. When students take part in interdisciplinary learning, they are able to appreciate the value of what they are learning. Another practical approach which could be used is multidisciplinary teaching. This approach focuses on one theme throughout all the subjects and combines them all as one. It shows the relationship of all the different subjects as it joins them with one shared theme. Lastly, there is transdisciplinary approach. This approach involves the teachers to organise and complete the curriculum around the students' concerns and queries. This is developed in two ways. The first is project-based learning, and the second is negotiating the curriculum. In 1993, Berlin and White released a paper on integration of science and mathematics, what parents can do. They argued that parents should encourage and support their children in finding links between science and maths, as this leads students to become more aware of the science and maths connections around them in their everyday lives. Berlin and White also discussed how such an environment would also have to rely on a wide range of content, such as involving technology. It would leave children in using tools such as calculators, computers, and laboratory apparatus. This would also expand positive and effective experiences. The use of IT within science and maths has changed the nature of teaching and learning. Children are able to use interactive whiteboards for problem solving, whole class teaching, and active learning. It gives them the confidence they require in order to use technology in their integrated maths and science lessons. Mosley et al. State that the interactive nature of multimedia software motivates pupils and leads them to improve performance. Calculators have also upgraded and become more advanced, allowing children to be able to complete more complex problems and equations. Jarrett supports this idea of how technology can be incorporated within maths and science. Although there are many positives in using ICT, there are also some negatives, such as timetable issues. It can be a time-consuming process in allowing children to use laptops and tablets. This issue applies more towards younger students. Students may also need to share most of the ICT equipment, as there may be a limited amount due to the cost of it all. To conclude, it is evident through the historical research that cross-curricular approaches within science and maths, as well as other subjects, is an issue which began many years ago. It is clear to say that there are many links between science and maths which teachers can use to apply a cross-curricular approach. This can also be improved with the help of technology integrated with these subjects. Within practice, teachers should be able to create effective as well planned lessons in order to help advance cross-curricular teaching. Children should be given the chance to be able to find the links between subjects, as this evidently helps them in the curriculum with the real-life problems and also in their future.